Alright, your General Electric Diesel, General Electric Dash 7 Series Section 11 Load Testing. Alright, introduction, self-loading, description, test equipment, preparation for test, load testing, the troubleshooting low output locomotive, self-loading curves, restoring locomotive for service, external loading, description, testing equipment, special tools, preparation for test, power plant operation, voltage regulator check, engine speed check, engine overspeed check, load testing, open circuit voltage check, current limit check, output curve check, setting power match, description adjusting power matching, procedure for setting power matching, external load curves on the EM99 loading unit, and restoring locomotive for service. Introduction. The section provides information for the load test for the Series 7 diesel electric locomotive divided into two parts. The self-loading dynamic braking resistor grids connected with external loading like the 17EM99. Figure 11.1 knot speed along the self-loading resistance line, output current ampere DC, terminal voltage DCs. Each loading method can have certain advantages listed here in the comparison. Self-loading, this is very quick to check locomotive output, engine horsepower, very little setup time is required. 0 to 10 volt DC meter is only the test equipment needed. An excellent mean for the test nearly allow the system of the locomotive, although it is done with a signal value of the resistance figure 11.1. It will give the output for 8 throttle notch positions. It can be accomplished almost anywhere with the locomotive railroad property, preferably in an inside building, since this could be overheat with the sprinkler system caused with other problems. During the summer, the hot engine alarm may ring on the locomotive. The engine itself may not be running at its correct operating point. It may not be put onto the normal horsepower due to action temperature derater of the overspeed link. It also will not run a normal intake manifold water jacket temperatures. Horsepower measurements will not be as accurate as by other methods due to the use of portable meters and current and seldom measured because of the time related to install a shunt. Alright, external loading unit. Horsepower can be measured with great precision, high accuracy. Accuracies of 1% are not usually, since better meters are normally provided with the load unit permanent load box stations. Operation can be continuous due to the absence of the hot engine alarm system. Engine running under the normal temperature conditions while unloading unit with this opportunity to select several resistant values with the test must be excitation curve figure 11.2. During load test and power matching can be set with or checked. Self-loading description: diesel electric locomotive with a feature that can be isolated with a multiple unit that consists of the dynamic braking resistor for electric load, with can have its own power output. The engine speed excitation system check for each of the 8 throttle notches that can be done without uncoupling locomotive from the others in a very short period of time. Result of the test will quickly determine if the locomotive is suitable for the continued service to repair, or if repairable, if it should be shopped in a serious malfunction. Locomotive is equipped with a self-loading feature and in the self-loading light on the engine control panel. Figure 11.2 shows the knot speeds along the 10 resistant line for the EM99 loading units. Output current ampere DCs, terminal voltage DCs. Figure 11.3 for the loading box toggle switch located in the top left center upper control compartment. The switch is mounted with the instruction plate. Figure 11.4 for the C37 models locomotive with the instruction plate with the other models same except for the value of the table 11.1. Causing prolonged testing with the ambient temperature above 65 degrees could damage the equipment due to excessive heat. Figure 11.3 location of the self-loading box light on the engine control panel. Indication of the light engine control panel. Figure 11.4 typical self-loading toggle switch, instruction plate load box toggle switch, self-loading normal operation self-loading procedure. Table 11.1 instruction plate values, model first, second, and third. Testing equipment 1.3 0 to 10 voltage digital voltmeter. Preparation for test. Locomotive to be self-loaded with electrically isolated from the other locomotives that consist of the multiple unit of locomotives done with the uncoupling 27-point multiple units at each end of the locomotives under the test. The air brake must be properly set to prevent possible movement during the test. The individual locomotive should also have the wheels chocked or blocked to prevent application power with the traction motor circuit close to the air supply air at the control with an NS1 reducing valve. Open the control air reserve, drain the cock, and insert the insulation between the main contacts, S and P contactors. Since some of the motor fields are in the circuit during the self-loading, do not test the damaged traction motor or traction motor. Cut out other defects in the power circuits. Before starting the test, check all the radiator cab intake screen with the underscreen and the underside of the radiator to be sure that they're clear and free of the debris, including ensure the proper cooling. Loading meter operator console is bypassed during the self-loading external ammeter with the shunt may be desired if it is so connected to the shunt series of the ACCCL reactor, keeping the alternating current alternate continuous current rectifier in circuit. The air cooling the brake grids are also passed through the radiators with the cool water. The ambient temperature get to high warm alarm ringing after the heat arises from the water temperature. Load testing on Series 7 locomotive with a continuous horsepower excitation current excitation system. Quick verification horsepower output can be made with the use of one digital voltmeter with a 0 to 10 volts in DC range. From the test point for the MP car FT735, fourth position from the left, multiplied by 300 kilowatts of volts, calibration 1.41, conversion factor 1000, as a good indication of locomotive output. This can be verified using the readings current from the alternating continuous current rectifier, 600 amp AV test point with the face of the FL card FT738 filter card, 7th position of the left on the FL138 panel. Figure 11.5 to any of the common test points, voltage of the voltage current reactor and the brake continuous reactor. Motor of 150 to V to V ratio, brake of 100 amp volts to a common test point for each of the comparison output curves. The figure 11.7 and 11 to 11.15 include the scale for the actual value for 0 to 10 meter volt readings. The two readings can be plotted on the output curve directly. To convert the meter readings to actual values, multiply the indication by 600 and 150, respectively. The numbers printed by side the test point of the values can be plotted on the output curve using the actual values for the voltage current. Figure 11.5 shows the FL138 continuous horsepower excitation current excitation panel with a high voltage section exposed. The reset toggle switch, the reference car variable, the high voltage section, parallel mounted paniometers with a cover, and voltage module, including voltage continuous current rectifier reactor. Figure 11.6 shows the location of self-loading toggle switches, LBTS, instruction panel, the ground relay, push buttons, engine temperature, holding temperature, annunciator panel, holding relay, customer option, ground or holding relay, load box toggle switch, open voltage relay, over push button. Let me check this, and I'm not sure if I read. Alright, it seems like I haven't read this one. With the throttle hand in the off position, reverse handle forward, the engine idle with the operating temperature, snap the load box toggle switch or self-loading toggle switch in the upper control panel to the self-load position, figure 11.6. The light over the engine control panel should now figure 11 light, figure 11.3. Throttle handle can be moved to each of the 8-notch positions. Engine speed for each of the notches is the same as the normal motoring. Output for each of the throttle can be compared with the corresponding point on the curve of the verified locomotive output done with the plotting of each of the meter readings from the take of the particular throttle position on an appropriate curve for a model locomotive being tested, figure 11.7 through 11.15. And note, if the points do not point along a resistance line, refer to the schematic diagram for the locomotive being tested, verify the combined resistance can be different from the one shown. Troubleshooting low output locomotive trigger. Further diagnosis recent partial output, but it can be undertaken by 11.2 and 11.3. Restoring locomotive for the surface of the movement toggle of the the load box toggle switch and the run position. Remove all the test equipment. Restore all circuits with normal, which may have been modified for the test. External loading. Description of load test should be performed periodically to ensure the locomotive power plant is producing rated horsepower, especially for the major overall power plant replacement equipment. Restriction is guided in checking the output for the power plant using the EM99 loading unit. The loading testing may be applied with adjusting output whatever an overhauled engine to determine the condition of the engine while the surface of the locomotive tabulation with the accumulated test data can be aid determination effectiveness overall work with the rebuilt engine guide maintenance work to improve the engine performance. This instruction assumes that an underground resistor blower type of loading unit will be used. However, it does not prohibit the use of any other loading device or unit, since the test preparation connection procedure will be similar. Alright, your item problem possible cause correction. Electrical items. The 1E locomotive 1E the problem. Low current voltage problem possible cause voltage regulator failure or correction. Reset the rheostat or replace the rear panel. Item E2. Problem. Locomotive voltage power supply of the current horsepower excitation panel 15 plus or negative 15 volt DC faulty FD740 RG card. Place repair FD740 card. Item 3E. Reducing excitation motor operation LED on the FD734 card. Problem. Possible cause of any defect continue with the turn of the FD card false turbo signal wheel slip signal correct the file move the switch to reset position defective FD card replace the repair FD733 card. Alright, the item 4E local problem low excitation operation inaccurate test meters reset the calibrated meters traction motor cut out reset switch high lube oil temperature check oil cooler operation FD738 filter card out of the calibration replace card or overspeed regulator. I guess ORS engine governor solenoid energized in an error fixed circuit externally strenuous signal on the H terminal with a continuous horsepower excitation current panel speed. Check the speed event with the wheel slip outputs. Beds, continuous measurement resistor and alternating continuous current reactor replace reactor. Item 5E, low alternator output. Possible causes. Power limit switch in notch 7 position. 400 600 horsepower low in notch 8 only. Reset switch to normal. Running single phase. Check each phase voltage. Filter cards. FD738 output out of calibration ACCR VCR. Replace the AC. Check the ACR and VCR. Alright, mechanical items. 1M. Poor combustion. Incorrect pumping timing. Retime engine. Incorrect value. Tappet clearance. Readjust proper clearance. Air leaking for the intake manifolds. Elbows. Turbo intercooler. Replace O-rings. Broken manifold section. Rack not set properly. Readjust the injection pump rack to set same correct setting. Carbon buildup in the cylinder inlet port. Remove the air inlet manifold and clean the ports. Fuel low has low heating values. Submit the sample to the lab test. Faulty fuel injectors. Replace bad injectors. Mechanical item 2M. Overspeed detector. Overspeed derailleur link expanded. Possible causes. High ambient temperature clearing intercoolers, air side and water side. High manifold temperature clean the intercoolers, air side and water side. Low oil pressure faulty pump or regulator overspeed governor. 3M. Item 3M problem. Low fuel oil pressure. Possible causes. Plug filter elements. Replace elements. Plug strainer. Clean strainer. Regulator valve set low. Recalibrate valve. Selection pipe emitting air. Tighten fittings and replace tubing and piping hoses. Item 4E. When provided, engine control and problem with the engine control governing modulation. Possible causes: low lube oil pressure correct cause of low pressure. Low water pressure correct cause of low pressure. Item 5M. Low turbocharger speed. Possible causes: cooled lube oil let system warm up. Bearing problem to replace turbocharger. Carbon buildup replace turbocharger. Item 6M. Engine control governor malfunction. Problem. And possible causes: air leak in the manifold. Replace in men tube. Air sensor malfunction. Replace governor. Load control pilot valve unbalanced to 0.344 inches with air. Okay. Replace governor. Binding fuel linkage. Clean free and lubricate. Alright. Table 11.3 exhaust smoke analysis. 1. Black smooth smoke puffs. Indication. Possible causes: more defective injectors. Correction. Reduction chain of the defective injector. Fuel pump rack is stuck. Free the rack and change the pump. Fuel rack is set too high. Locate the high rack of the readjust. Fuel pump rack is out of time. Adjust timing. Warn damaged turbocharger. Replace and repair or replace turbocharger. Broken leaking manifold pipes. Repair and replace manifold. Engine speed blocking down. Check the engine operation circuit for the fault. Turbocharging surge inlet ports partially blocked and turbocharger misassembled. Nozzle ring or diffuser. Clean inlet ports if dirty. Turbocharger rotor is stuck. Replace turbocharger. Alright, white smoke puffs. Indication of the fuel pump is out of time. Adjust the timing. Cylinder valves are burned is stuck open. Replace cylinder. Engine is too cold. Wait until the engine warms up. Cylinders with low compression. Replace cylinder. Fuel system airbound. Bleeding the fuel system. Alright, a blue smoke, indication of blue smoke and oil out of the tank. Possible causes: failed turbo bearing seals, replace turbocharger, worn broken piston rings, replace rings, track piston crown, replace piston and rings, scored liner, replace cylinder and rings, prolonged operation of the idle load engine conditions should be clear up. 4. Steady smoke. Possible causes: worn leaking injectors, change injectors, late pumping time on all cylinders, time the injection pumps. Item 5. Water out of the stack. Possible cause: cylinder seal leak and cracked turbocharger, locate and correct. Blow in exhaust system. Possible causes: broken exhaust manifold section repair, replace manifold and manifold section. Valve tappet clearance is insufficient, replace some valve tappets. Cylinder valve is stuck open, replace cylinder. Cylinder valve is guttered, replace cylinder. Alright, warning. To prevent against fatal injury from the electrical shock, do not proceed with the load test until the frame of the loading device for the locomotive are properly grounded. Test the equipment and special tools. Locomotive loading device with a connection cable to meters recently calibrated to 1/4% accuracy from the loading unit with the EM99 or water box arrangement part and number FEM99D1. And meter calibrated shine if the motor loading device is not accurate. 0 to 6000 AD alternating DC or amp DC. Voltmeter if the meter loading device is not accurate. 1 to 1500 volt DC voltmeter. 100 to 450 volt DC tachometer. 0 to 1500 RPM. Overseat test lever. Alright, and then it goes into figure 11.7 self-loading AB B1817. You have your voltmeter reading 100 volt, the volt alternating rectifier current characteristic curves, read self-loading, and your AC meter reading it at 600 amp over the volt. Output current DC amperes, terminal voltage. You see alternate rectifier currents curves B187 over terminal voltage DC. Average brake reading self-loading of the B 1817 on its own dynamic braking grid of 0.76 ohms resistance. Notch 8 through 1, the ACCR card, the VCR card, the power card on the left curve, and the current right curve of the current amp, the voltage, volts, power kilowatts, power horsepower. Preparation for testing. For test, check the block of the wheels during the test to prevent possible locomotive disable the power match failure feature during the load of the test. If the locomotive is equipped lifting the wire with the terminal, apply the jumper between the terminal EXPL and EXPM for FL138 excitation panel. The desired unload the air compressor for the duration of the test. Jumper of supplies of 70 volt, 5 volt DC to the coil magnet valve. This keeps the compressor from loading, which would cover the extra load of the engine. Load testing connections refer to locomotive schematic connection diagrams. Alright, disconnect all traction motor cables with the positive terminal regulate and power rectifier panels. Do not disconnect the small control with a GA since they require to control system connection of the possible cable for the loading device and possible motor cables just removed. Alright, figure 11.8 self-loading AB 23.7. Once again, you have your voltmeter reading at 150 volts to volts, and your ACR meter reading a 600 amp to volt. In the left hand, on the right hand table, the terminal voltage DC over the output current DC amperes. Average braking reading is a self-load of the B3023.7 locomotive with dynamic braking degrees and 0.76 ohm resistance. Notch 8 through 1, AC card 7, VC card 7, power card 4, left curve, right curve, current amperes, voltage volts, power kilovolt watts, power horsepower. Figure 11.16, assure for the load testing cable with our sufficient size for the safety handle with the maximum load current. Even if it's have thoroughly insulate the cable lug, then remove it above so no contact can be made at any time during the test. Note, when connecting the cable to the wire lugs, be sure the lugs are flat, clean, meeting surface may be sure of the correct size quantity. If the hardware is used properly to make the connection, apply the joint compound TBM53 number 21059. GE41A204944P1. This will prevent hot spots in the connection, prevent lost power. B. Disconnect the insulating the traction motor cable of the current reactor. The alternating current continuous current in the reactor is lower than compartment figure 11 to 17. All load current must be passed through the alternating continuous current during the test. All do not disconnect the GN wire from the load test with the circle the negative cables over the load device for the negative of the reactor. Show the load current passed through the reactor during the load test include a current measuring the shutting of the negative cable of the loading device. An accurate load meter is not built into the loading unit. Figure 11.9 shows self-loading C23.7. Once again, you have your voltmeter, 150 volts over the volts, an AC meter reading as current amp volts. The C23.7 output current DC amperes, voltage terminal VCD voltage over the terminal voltage volt DCs. Match 8 through 1, AC card 7, VC card 7, power card 4, left curve, current amperes, voltage volts, power kilowatts, power hour, power horsepower over the right curve. Alright, warning, proper precautions must be taken with the person with a possible contact with a high voltage meter wiring. Suggest all the meters for the clove of the large box with a clear plastic protect the cover. If there's no accurate voltmeter loading with the device for the connecting 0 to 1500 volt DC voltmeter across the power rectifiers terminals GA to GN. This is an important cable to see from the loading of the device with the sufficient side of the quantity to keep the voltage drop of the cables at the minimum. Note it's important that all the meters used in the load testing are accurate, calibrated with the accuracy of the meter calibration will determine the precision of horsepower calculation. Digital type of the meters recommended to do the retention from the calibration. How do you not apply with the voltage? Because after these ratings, always unplug from on way side during the usage. Connect 0 to 150 volt DC for the reverse current diode panel, 17 FM 203 for the cathode side of the 4 wire or N wire for the battery charging. Alright, figure 11.10, self-loading B28.7. The B27 alternator rectifier current characteristic curve self-load notches 1 through 8, the voltmeter reading of the 150 volt, the AC reading of the 600 amp volt. On the left, you see the terminal voltage display with the knots 1 through 8, output current DC amperes. Average reading brake for the self-loading B28 the locomotive on its dynamic braking grids of 0.76 ohms resistance. Notch 8 through 1, ACC card 7, VC card 7, power card 4, left curve, right curve current amperes, voltage volts, power kilowatt, power horsepower. The circuit of this meter will read the charging voltage. Do not attempt to read the battery voltage across the blades with the battery switch across the voltage regulator. Install the 0 to 1500 horsepower tacho generator meter tool of 2X2795 with a matching digital meter to the engine. Apply with the tachometer generator of 1/2 inch. Pipe plug open between the overspeed governor on the right side of the engine. Figure 11.18. A hand tachometer with extension can be used by applying in the same location. Shut off the air supply. The NS1 control air reducing valve to drain the control air reserve to prevent impossible operation contact during the testing on the remove the insulation battery power wire EF from the EC engine control switch with the reverser of the ground to the GOL or interlock to eliminate the control power from all the power contactors. If the corrected horsepower check was made with measuring the fuel temperature fuel line engine between the secondary fuel filter and header. Read the ambient temperature and barometric pressure for the just before the after horsepower. Alright, self-loading C28.7 voltage notches 1 through 8 and 1 through 8 on the scale voltmeter reading 150 amperes on the scale of 1 to 10, 1 to 10, 1 to 9 ACR meeting reading 608 amp volt self-loading 0.51 ohms, and then the horsepower curve is on the bottom. The voltage terminal voltage relay 0 to 1400 volts terminal 1500 volts. Notch 1 through 8 volt itself at the bottom 0.51 ohms for curve at the bottom of the output current DC amperes 1000, 2000, 3000, 4000, 5000. Average brake reading self-loading 628 locomotive line this dynamic braking grids to 0.51 ohms resistance. Notch 8 through 1 ACZ card 7 VCR card 7 power card 7 left curve right curve current amperes voltage volts power kilowatts power horsepower. Check the load test. Accurate barometers is not available. The evaluation of the test. I see the calculated gross engine output loading testing instructions under section ET2 of the maintenance manual. Power plant operation. Check the engine for the proper level of the cooling water, lubricating oil, fuel, oil, governor oil, so that the load can be tested complete without stopping. 2. Check the level of the lubricating oil in the air compressor, traction generator, gear unit, radiator, fan gear unit. Check with the fuel linkage system where the engine for the is properly lubricated whether it operates freely. As to check out for what pressure with the fuel oil pump, it should be 40 psi. Check all rotating apparatus loose or broken. Brush with any foreign material. Correct any unsatisfactory condition before proceeding. Self-loading self-loading a B37. Alright, notches 1 through 10. The voltage meter reading is 150 volt with a 10 scale of 1 to 10. The notches 1 through 8, and the self-loading is 0.74 ohms. The 360 horsepower in the center of the 297 horsepower from horsepower shown in the notch, each of the notch curve on the bottom of the ACR meter reading 60 amp voltage. Terminal voltage VC 0 to 1500. Notches 1 through 8, the self-loading limit on the top curve, and then the horsepower on the bottom over the curve. Load 1 not through notches or the inside line to outside line. 1 through 8 on the output current DC amperes. Average dynamic for self-loading B37 locomotive unit diameter braking grids is 0.76 ohms resistance. Notch 8 through 1 ACC card 7 VC card 7 power card 4. Left curve, right curve, current amperes, voltage, volts, power kilowatts, power horsepower. Check that no warning devices trip such for the engine air filter indicator. Remove the air supply hose, the overspeed fuel control device, overspeed linkage under the engine control governor at the device with plug the hose fitting. Preset the loading device for the high resistance of the current circuit prior to the starting of the engine. Check the circuit through the loading device is open during the engine starting to minimize the drain of the battery. 7. Start the engine if the engine is overhauled. Follow the braking procedure listed in the publication found in section DE 15 with the maintenance panel. Check with the system leak for any of the signs. Destroy for the current correct with any faults for the proceeding. 8. Turn off all non-essential auxiliary loads like the lights and electrical cabin heaters, the water coolers, and also the battery to be fully charged. The derailleur linker must be in the derating. Fuel restrainer fuel filters must be clean. Figure 11-13 self-loading a C37. Voltage reading from 1 to 10, 8 notches 8 through 1. The self-loading unit line at 51.1 ohms. Then the ACR meter readings on the bottom, 100 watts, 275, 575, 6, and 968, 1440, 1430, 250, 200, 2900, 3070. Terminal voltage you see over the output DC amperes, the voltage notch 1 through 8 on this 1500 horsepower terminal voltage DC, and the horsepower on the bottom output current DC amperes. Average reading self-loading C37 on locomotive on its dynamic braking grids of 0.51 ohms resistance. Notch 8 through 1 ACC card 7 VC card 7 power card 4. Right, left curve, power, right curve, current amp, the voltage, volts, power, kilowatts, power horsepower. Check the power limit switch for the operator console that's zero for the normal notch 8 and the notch 7 position. Voltage regulator check. And before proceeding with the load test, check with the voltage regulator proper regulation between 73.5 and 74.5 ohms, both idle and full engine speed. Read the voltmeter instead of the battery charging circuit. If the correction is needed, loosen the lock nut on the pentameter with the tape of the regulator panel, either FH20 or FH23 to turn the adjusting screw obtain the proper voltage, then again to tighten the lock nut. Engine speed check. Run the engine in notch 3 and 4 until the water temperature is 60 degrees Celsius or 150 degrees Fahrenheit or above. Check the engine proper. Check the crankshaft speed with all the notches. Prefer the engine control governor instruction with adjustment. If any adjustment, F or tachometer should read 1553 to 1568 RPMs with 1045 to 1050 RPM engine speed. Self-loading B36.7, your voltmeter reading the 150 volt ACCHR meter reading 600 amp volts, the notches 1 through 8, and the horsepower on the self-loading 57 ohms. Terminal voltage DC 0 to 1500, 0 to 1 and 1,000 incrementals on the output DC amperes. Show the notch 1 through 8 and the horsepower and self-loading ohms. Average reading and self-loading of the B36.7 locomotive on its dynamic braking grid with 0.57 ohm resistance. Notch 8 through 1, ACC card 7, VC card 7, power card 4, current amperes, right curve above the voltage volts, power current kilowatt, power horsepower. Engine overspeed check. When the engine heated with the normal operation temperature, check the idle don't load with the plate for the official overspeed test with the lever of the tool 147X2016 under the outer coupler with the overspeed link with the X1129 with the reset for the back fits over the head with the clamp bolt with the fuel arm connect with the bottom of the link with the pivot pinion with the test lever. Press down on the end of the tool to raise the bolt with the overspeed link with the governor power piston out to push shaft with the stand with the rack increase the engine speed with the trip point with the overspeed governor reach for the damps the dump the oil pressure into the link with the link is then permitted to extend and return the racks to the shutdown position. Read the engine speed on the digital meter at the movement. The overspeed link extends. Load testing. Note, load testing accurate according to local railroad safety regulations. Alright, figure self-loading C36.7. Notches 1 through 8, self-loading 0.51 ohms, horsepower readings, IACCR meeting 600 amps over the voltage meter reading of the 150 volt voltage volt. Terminal voltage GC 0 to 1500, output currents in 1000 degree increments, DC amperes. Self-loading 0.51 ohms, alternating rectifier characteristics, and horsepower. Notch 8 through 1, ACC card 7, VC card 7, power card 4, left curve, right curve, current amp to voltage, power kilowatts, power horsepower. Open circuit voltage check with the engine normal operating temperature above 60 degrees Celsius, 150 degrees Fahrenheit, and proceed as follows. Move the brake handle to the off, reverse the handle with the forward reverse position, move the engine control, switch to run, then close the GF circuit breaker. The warning electrical shock can cause serious fatal injury. To avoid such injury, personnel must observe proper precautions. Self-loading device open circuit the close with the circuit close the control circuit breaker with the engine control panel. Move the throttle handle to notch 4. Observe the testing voltmeter that has been properly connected. Give it the positive reading. Check with the voltage lower notch for the ensure the excitation system operating properly. That will not be produced. Says the voltage in notch 8, which could severely damage the equipment. Gradually advance the throttle notch to notch 8. Checking the open circuit voltage for each. Each notch never allow the voltage to exceed the given no load characteristic of the figure 1124 through 1132. Small chain with the open circuit with the notch 8 that can be made with the resisting of the VL pentameter, the third pentameter with under the right and the cover of the continuous horsepower excitation current channel. Otherwise, proceed with the current limited check. Make any required adjustment to the CL8 pentameter 4 with the repeat the open circuit voltage check. 5. Where the air compressor running unload the voltage meter across the power rectifier the open circuit with the voltage should be plotted between the limits and shown by the appropriate characteristic curve. The zero curve. This is that a zero current on the left end of the end of the curve in the C figure 1124 through 1132. For proper module locomotive being tested, return the throttle to the idle position. Figure 1116 substitution load cable at the positive terminal of the power rectifiers. Installation sheet of the cab terminals, GA control wire, positive cable, the traction motor, positive cable loading device. Figure 1127 substitution loading cable, negative terminal, AC, alternating current continuous rectifier reactor, ACCR, GN control wire, negative the cables from the loading unit. Current limit check with the thread with the loading of the unit with the minimum resistance of the throttle has notch with the air. Compressor running on the load to take the voltage current reading the point with appropriate load curve the figure 11.4 through 11.32. The caution do not hold the high current load any longer than necessary to protect the equipment against the power high to preserve the image of the develop the high current. Gradually advance the throttle and the notch 8 while watching the ammeter to make sure the limit is shown on the curve overrun and read the meters. Figure 11.18 measuring the engine speed of the tachometer driving the fittings on the governor drive gearbox. 11.19 increasing the engine speed with the speed overspeed test lever tool. And the pilot in the pilot point with the nearly vertical right end of the curve of the point should be followed between the curve of the line and line of the point plotted with a notch forward with the original left corner of the curve. The adjustments are required to adjust for the rheostat and give it the current value with which will fall within the limits of the curve of the resistance being used. The line should be coming across the curve somewhere below the low right corner point. Check the load control panometer or LCP with the brush arm. The engine connector control governor is operating at 5:30 o'clock with the maximum field position. Return the throttle handle to the idle position. If the rheostat was adjusted, repeat the open circuit with the voltage. Determine that it is so with the curve limits. And since any adjustments made, change the envelope size for the whole curve. Or your output curve check. Note that the curved portion of the load curve of the constant horsepower section from the resistance step of the loading device must be selected to get the points in the select section. Select a resistance step on the loading device. Move the throttle handle with the notch A with the plot the point with the appropriate curve of the return the idle. Make another selection of the resistance loading unit with repeat the number of the points of the check within the manner however the annually resistant values available to the loading device may use. Should not hold the high current loads any longer than necessary to protect the equipment against possible damage due to the high temperatures developed in the high current. Refer to the FL138 excitation panel instruction and additional information for operation load control panometer and this engine control governor with the near standard test condition, but the indicator should not go less than about 4:30 o'clock from maximum field position until 5:30 at any time during the horsepower curve check. That it should, if done, it does go to the lower value of the. Refer to the excitation panel instruction possible cause of correction. The curve of the figures 11 through 24 through 1132 are based on the standard 1, 2, 3, 4, 5, 6, 7, 8 and the speed with the power matching disconnected. All steps of 110 resistance are from for an EM99 loading unit. Other resistance can be used with the valves applied on the same curve that found necessary to load some of the other devices. The EM99 step resistance are given the heading table of each curve figure 1124 through 1132. Setting power matching. The description power match feature is required to protect the traction motor for the same locomotive. Some locomotives, when working with the multiple older units to prevent damage or to reduce the life of the motor, the feature works during the first step of transition being passed by any other. The only high current with the slow speed operation from locomotives is modified. If all the locomotives dispatched consist with the same mode with the same gear with the wheel side with the corresponding with the short time rating of the power matching will be not necessary for the power with the consistent locomotives is seldom made with the units with similar ratings whether other same manufacturer, different manufacturer. Any locomotive operating continuously for long periods of time, speed lower than continuous rating, need for the feature with the protective device unless the high horsepower locomotive is leaded unit. When operating crew is riding with the crew is unaware of the traction motor overloading while slipping the smoke of success for the crew with the watching load meter will be left for the restrictive time limits. Alright, note, normally locomotives with the protection of the D-ray with the corresponding bolt loss with the available the horsepower with the train starting with the slow speed operation apply with even with the operating alone with the others with the same level with the setting with the power mass of the variable. This is important to have the readjusted when with the type of the locomotive causing the problem, determine the setting with the transferred to another territory or retired from service. When the properly set power matching will protect the traction motor overheating of the installation, the shortening of the useful life, the reducing of the current through the motor for the compatible with the rating for the motor of the other locomotive operating with the multiple unit. Note, do not confuse the power matching with the power limit with the toggle switch for the operator with the console with the non-step with the normal position if the provided with the lead locomotive condition with the rail trailing locomotive per minute. However, average traction effort over the grades and a higher speed with the otherwise possible. Power matching is also known as performance control applied with the competitor's locomotive. The periodic survey should be conducted of all locomotives to work together given the territory to determine if has been changed with the restriction on all pooled power. If it could all allow the amount of the power matching to be adjusted to utilize the power of the available power. They eliminate the power matching altogether on each locomotive at the lower speeds. Example of the application of the power matching assuming the locomotive number 1 is an older unit with a continuous rating of the point C1 with the speed traffic efforts curve. The fixed 1121A. The second has higher horsepower locomotive number 2 with a different continuous rating point C2 on the same curve. Since the two locomotives are coupled together and must pull the train at the same speed without power matching number 2, we normally operate with the point A when locomotive number 1 continuous rating with its current speed exceeding the continuous current rating when transported alternator rectifier characteristic curve of figure 1120B with the points A, C1 and C2 may be located in figure 1120C. Alright, point B is determine the same speed as C1, but the same traffic after the same current with the like motor for the gear for the C as C2. Then transpose for the point with the reduced horsepower output curve figure 1120D set of 3,000 horsepower. During train acceleration, the power matching in locomotive number 2 would be then cut to the D file with the reducing output curve to the B, then transferring back with the full horsepower curve of the C2 continues along with the curve. Remember the reduction was made through the after the transition coming back along the horsepower curve the next time. Power point C2 is referred to as the knee, and line BD as the level of the segment of the power match figure 1122. Adjusting power match, the continuous horsepower excitation control excitation panel figure 11 FL 138 has two adjustments power matching located in the high voltage curve right into the panel along the 6 other panel mounted with 20 turn pentameter for lower 2 turn pentameters number 7 and 8 set the knee at the level of the power matching. All adjusting are done with a very small insulated screwdriver. Figure 1121 detailed with adjustment clockwise reduces the bowl setting, the counterclockwise increases them. There's no standard setting for the power matching. Each railroad determine the proper setting for each of the locomotive and each of the territory. Be sure to follow the latest railroad instruction checking and changing setting. Alright, and then we're going to sketch out on this. Determine the setting for the power matching. Alright, your traction effort will be on the LB side on the figures A and C. And they have C1 and C2 with the train speed miles per hour. Locomotive number 1 at 28 horsepower. Locomotive number 2 at 3,600 horsepower. And then B is the traction effort of the LB train speed. Locomotive 1, number 2,800 horsepower. Locomotive 2, 3,600 horsepower. A, B, C, 1, C2, and D, speed traction effort. On the right, the terminal voltage volts over the current amperes. The alternating current characteristic curves over the constant output portion of the curves. C1 and C2. Terminal voltage, current amperes, 2,800 horsepower, 3,000 horsepower, 3,600 horsepower, C1, C2, B, A, and D, alternating current rectifier curve with the constant output proportion with the curves. Alright, figure 1121. Figure 1121, adjusting the power of the matching knee. Procedure setting power matching with the connected loading with the active of the power matching feature with the removal of the jumper between the terminal EXPL, and the FL138 continuous horsepower excitation control excitation panel. Set the load unit on any of the steps in which the resistant line will cross the DB and BC2 line on the figure 1123. The gradually increase the throttle handle with the notch 8 reduces the voltage and current, then should plot with the characteristic curve of the intersection of the power matching lines. Set resistant lines if not the level, and the knee should be adjusted. Figure 1122 shows the P79 and P8 level, P level and the P8 level adjusting details. The C counterclockwise continues clockwise. B, P79 knee and P8 level the counterclockwise and clockwise. Figure 1123 setting power matching while on the EM99 loading unit. They have a terminal voltage and voltage EC. Output current AM per DC, steps 1, step 2, step 3, C2, B2, BD, steps 4, 5, 6, 7, 8, and 9, and 10. Once the knee and level that have been properly set with the recorder, the testing equipment can be removed. The locomotive may be ready for revenue service. Restoring locomotive for service. Remove all the test equipment, disconnect all the external wires and cables, restore all circuit breakers to normal, include the power matching if applied on the open the ends for reducing valve, close the control air drain cock, previously set the preventing locomotive movement, restore the air compressor control the normal, replace all the covers and plugs in the proper location, remove the tracks and blocks to prevent locomotive movement. Alright, and then it shows the loading of B17 EM, loading 919, reading terminal voltage VC output correctors notch 1 through 8. These are this show the notch steps 1, 2, 3, 4, and 5. Steps 1, 2, 3, 4, and 5 average readings. EM loading unit number 99 loading unit. Steps 1 through 10. 1 through 10 and for each B30, C37, B36.7. B36.7, 38.7, and that was this tape was the GE Section 11 Dash Series 7 Section 11 load testing.